Yeah,
Okay.
everyone's here. Okay. Assalamualaikum, good evening. So I am Shakaf from University Malaysia Perlis, also a consultant for Idea Senang Berhad lah. So today's talk will mostly be based on some of the projects that Unimap and Idea have been collaborating together to solve some of the industrial problems that are being faced by Idea's clients lah. So I myself is from mechatronics engineering, but Idea Cineberhad itself consists of various backgrounds lah. Let me share the slides first. Sekejap eh. Okay. Can everyone see the slide or just
Yes,
my
yes, it's good.
desktop?
All right, it's good. The
It's good.
slide is yeah.
Yep. All right. So, okay. Right. So I'll do a short introduction on Idea first. So this is our core members lah. Associate Professor Dr. Ahmad Zakaria, Associate Professor Dr. Latifah Munirah, Dr. Said, Dr. Yuzairi, me myself. We also have a few more system developers, Dr. Gochu Chet, Dr. Rena Viswanathan, Dr. Noraini, also our designer lah, Mr. Muhammad Nasruddin. So all of us came from various backgrounds, some from sensors, some from computer engineering, some from electronic engineering, me myself from mechatronics. Um, so quite diverse lah, right? So what we do is uh, we are a solutions provider, but we also do from grounds up lah, from sensor design until the application itself, right? So we have our academia partners and also our clients lah, right? So I think we can go straight into um, the meat of the talk today. So usually our students kan semua all of our research based students lah and also project based students pun you have your data, especially if your projects involve sensors, so you have a lot of data, as this image shows, can data everywhere and not a bite to eat, meaning that we have that data, but how can we translate that data into something more meaningful, so that we can give some insights lah. So today I will share some of the projects that IDERIA and also Unimap have been collaborating um, with industrial partners to solve real world problems lah. First, we have our air quality index prediction. So SysTech has been involved in developing air quality sensors for how many years ada tu saya? 20 years ada. 15 years. 10 to 15 years already. So this is so this module, this air sense by SysTech, this one is from 2020, I think, 4 to 5 years ago. Right. So in this air sense module, we have a lot of sensors incorporated in it. Various air quality sensors like you have your um, PM10, PM2.5, PM1, CO2. It's also combined with GSM and GPS, temperature sensor, and all the microcontrollers and so on lah. So all this is incorporated into one module, enable for us to collect air quality data. Since this one have GPS and GSM modules, we can also use them in vehicles. So this round air quality module is actually made for in-vehicle air quality index prediction lah. So we have all this sensor data. We have the vehicle position, We can also obtain the vehicle speed, um, temperature, relative humidity inside the cabin, right? Um, all of this data, but what can we do with it, right? So we at IDERA um, specializes in processing this data and try to give something more meaningful, something with insights, right? So with using this module um, and AI, which I will show. Okay, so this is the architecture of the model, lah. So we try to use this data to predict what is the air quality index in the future, so that this device can act as a early warning system if the air inside your car is getting dangerous to dangerous level. So of course, AQI, you have your um the levels lah, from zero from 1 to 5, I think. Um, from good to bad. And there are some mathematical equations that you have to um follow lah to calculate the AQI index. Um, but when we incorporate this module inside the car and the car is moving, the based on the car speed or the vehicle speed, the AQI um, may may differ between speed, right? So, but the speed parameter is not in the mathematical model of the AQI index. So, what we did 4 or 5 years ago, we used LSTM-GRU to estimate the AQI um, in the future after 5 minutes, 10 minutes and 20 minutes. What is the AQI that we can get inside the car or vehicle? And um, we validate it back with the actual um, measurements that we get lah. So using this GRU prediction model, we can actually get quite good results for short-term prediction. But as you can see, from 5 minutes to 20 minutes, the prediction gets a little bit more inaccurate lah. So for short-term prediction, it can work fine. So it is suitable for an early warning system for safety lah. Right. So from that project, we have been working together with Nano Malaysia and also Prof Azhar, I think, with on this AirSense 360 project. This AirSense 360 is an upgraded version of our AirSense by Systec lah. AirSense 360 has better sensors, better. We also have graphene based sensing material on it. And we try to develop an air quality index punya device that's good enough to be deployed in sterile environments, which are required by hospitals lah usually, right? So what we did with this module, we incorporate our sensors with various communication methods lah. Before this, we use the module before we use GPS and GSM, but this one we use Bluetooth and LoRa because this is being deployed inside a facility, right? And our current goal is to improve Sense 360 for it to be able to be deployed outdoors. So that's one of the products that we have developed based on fundamental research on air quality index. As I've mentioned before, we did some collaboration with Nano Malaysia. We deployed our Essence in hospitals. That is through our collaboration with UEM Agenta lah. But for UEM Agenta, the main project is for asset tracking and utilization. So UM Magenta is a contractor lah, the hospital concession. Betul tu side. Right, hospital concession. So they provide the equipments, the maintenance of those equipments, the anything related to medical equipments in hospitals, they provide those kind of services. So what they are currently facing right now is that they provide those equipment, but they don't have the data whether those equipments are being used or not, or if used, how often. If not, when is the last time it's being used? So, um, because they don't have that data, they are currently doing maintenance on this kind of devices by schedule. And scheduled maintenance will cost some money lah. So in order to reduce those costs, UM Magenta would like to move from scheduled maintenance towards predictive maintenance, meaning that the machines that or devices that are frequently used will get maintenance sooner. The devices that are rarely used will have their maintenance later on lah. So if it doesn't balance out, it will result in more or reduce costs for Agenta lah. So to do this, we deploy our tracking sensor on the medical device. The tracking device also have some our own in-house sensor that can detect um, whether or not the medical device is turned on or not. Right. So with the tracking device, we can track where the sensors are, where the devices are in the hospital through zoning lah. We use zoning using Bluetooth, right? So we know which ward have what kind of devices in the operating theater, what kind of devices is there, and those devices are being used or not. Is it if it's turned on? Is it in utilized? Is it being utilized or is it idle? So we provide those kind of insights towards Agenta using our own tracking technology, right? So the next step for this product is to incorporate wireless charging for our sensor tracker, right? Because right now the tracker itself is being powered by battery and there's no charging module on it. So there will be a time when we need to replace the batteries lah. Some of our devices also tap into the power of the medical device, which is not recommendable because you will void the warranty of those medical devices, right? So next step is to incorporate wireless power charging in our devices. Right. So where does the AI comes in? Based on the utilization of the device, right? Because we have our sensors there, we can detect the power level ke, how much current is being used. We try to analyze the signal that we get from the sensor, and we label the data. It's turned on, it's turned off, it's idle, and so on. So we have those kind of status, right? You can see in the dashboard here just now. Let me see. Right, we have our devices here, online or offline. So these two status here. Oh, I didn't turn on my laser pointer. So we have two status here. This green icon means the device is online. The yellow icon means the device is idle. So it is turned on, but it is idle. For the second device here, Angel AJ5812, it's turned on and it's being the status is unknown. This Fresenius 400 4008S here is turned on and it is being utilized. So we have this kind of status that we can get from the classification using AI based on the data that we get lah. So based on the status here, we try to provide a prediction of when these devices will need to be um, go into service or do maintenance, right? Okay, so that's two projects that I've presented, um, and both of these project involves Agenta lah and Nano Malaysia. The state one involves Petronas. This one is quite broad because we do have our once we did the tracking project with Agenta and it's proven with Agenta, and then the clients comes rolling in lah. Once the tracking is proven, Petronas came in. They want this somewhat same solution for their own use. But the difference this time they want to also track their manpower, their materials, and also since Petronas have a zero tolerance on safety in their fabrication site or construction site, they also want to detect the PPEs, right? Whether their workers are wearing the hard hats or not, safety shoes, do they wear their safety shoes or not? Things like that, which is very important for Petronas. So we try to deploy mm, the same technology in Petronas site, but since this construction site and fabrication site is quite big and it is outdoor, the Bluetooth that we used before is not quite feasible lah. So this time we use RFIDs and UWB, right? And before this we map our zones based on wards, operating theaters, and so on for hospital, right? For a construction site, they have their own zones lah. These are being provided by Petronas lah. Dia yang set which zone is which. So Petronas in Petronas punya site, the construction work itself is not being done by Petronas workers pun. Dia more on dia punya subcontractors lah. So dia punya project manager or site manager tu dia nak tahu where are all these subcontractors are located. Are they doing meaningful work, or are they just lingering around? Or the subcontractors promise seven welders uh, at a time, in one time, maybe dialogue here promise seven welders, but they Petronas actually wants to know those seven welders there on site during construction. Right. So we deployed our tracking technology, which is eye track, and we can track. So remember, Petronas wants to also track the materials on site, so we can track the spools, right? For Petronas construction, usually when they construct their gas pipes or um, raw material punya pipes tu lah, petroleum ke gas ke anything, those pipes are being welded from small parts until the giant pipes to siap and then bawa and then they will bring that pipe to the construction site, right? So using our tracking technology, we can track the progress of the pipe. Like these tiny spools here, where has it been inside the fabrication site? First, it's being welded, and then it goes to NDT. NDT is non-destructive testing. So here, the supervisors will check the welding work is up to par or not, right? If it's not good enough, it goes back to the welding site and goes back to NDT again for another check. If it's good enough, then it will go to sandblasting and then painting before going to the construction site. So by tracking the spool's movement, we can also get the how long does it take for a spool, this small spool here to become a much larger to become a part of a much larger parts of construction. So this tiny spool here took 2 months to be completed. So right, we're not sure if it's good enough for Petronas or not, but based on this data, this could quite lead to project delays lah. So this is the kind of insight we try to provide to our clients. Okay. Um, the next improvement that we target for this project is to incorporate um, explosion-proof trackers. And for PPEs, we want it to be able to be self-powered, so we can put a tracker on the PPE itself instead of using vision-based solution to get those PPEs. I will show you the vision-based solution. So this is the detection for PPEs. So this is one of the site of Petronas fabrication site lah. This one is in Gurun. So the workers here are. Is this a video or what? This is a video, right? Okay. So we use CCTV cameras to detect whether or not the workers of on the site is wearing PPEs or not. So the tracking is still not quite good, but this is just a matter of data lah. If we can get more data to train the model, we can get better tracking. Um, in this case, it's actually quite good enough for Petronas because they only this is inside, right? For Petronas, during the earlier part of this project, they only require the PPE detection at the gate, meaning that when the workers came into the site at the gate, we will scan for the PPEs. If everything is there, then it's all fine. This is just a proof of concept that we can also track PPEs inside the site itself, right? So we can detect the hard hat, and this is also another thing that we propose, right? Because Petronas also wants to know whether the subcontractors are doing meaningful work or not, right? Um, by using the same object detection method, we can also get activity recognition with some modifications, lah, of course, right? The same architecture of AI model with some time series adjustments, right? We can also get dynamic um, activities to be detected. So this welder here, this is the welding area of the site. So we have a couple of welders here. Through CCTV, we can detect the welding activity of the welders, right? So based on this detection, maybe we can get the timestamp. We can give the actual hours of welding being done by the welders, right? Okay. So the fourth project is logistic and fleet management. So as you can see, IDERIA is pretty specialized lah in tracking. So this is our in-house GPS tracker. This is from 10 years ago, I think, right? So we have our GPS GSM module on our in-house microcontroller board, which have tons of I/O that you can use to also incorporate other kinds of sensors. So we use this kind of GPS to track this shuttle buses of Unimap shuttle buses lah. There's around 50, I think, 50 buses in Unimap. Using our trackers, we can get the location. We can get the speed of the bus. We know which driver is driving which bus. Through this data, we can give an ETA of when the bus will arrive um, to the bus stops throughout the campus lah. Also throughout Perlis. Because if you haven't been to Unimap before, Unimap is kind of everywhere in Perlis. So this kind of system is actually quite helpful lah for the students and also for staffs who are using these shuttle buses. So as I said before, we have our sensor board have tons of I/O that we can incorporate other sensors. So in this case here, we incorporate a vibration sensor on our GPS module. Um, this is a POC juga for Penang Port. They want to know whether the vibration on in Penang Port itself, because the road conditions aren't quite good, because you have the prime movers moving around 24/7. They want to know whether or not vibrations play a part uh, during, how to say, because Penang Port drivers here, they suffer from back pains. So when they want to claim insurance from per keso macam tu, they will ask for evidence lah whether or not betul ke tak this kind of pain or accidents happen in the workplace, right? So they need this kind of data to convince the insurers to claim the payouts lah. So um the AI part of this tracker is mostly on the ETA, estimation of arrival. But this is just to show that any products or any solutions that you make does not have to be too specialized towards one solution. You can always improve your product. You can always make it a bit open-ended. So in the future, you can upgrade your solutions to cater towards wider problems lah. Right. Okay. So this is a smart city project that involves AI. Um, but this one is mostly vision based lah. Vision based. So this smart city project is collaboration between IDERIA and also PKNS. PKNS and its subsidiary company, which is SIC here. Um, s- this is Smart Selangor, like SIC is Selangor Industrial Corporation. So what SIC is doing is they are building a green and smart township in Cyber Valley, Cyberjaya, is it? Betul tak, Syed? Cyberjaya, right? Smart Cyber Valley. So in this first phase here, we are only concentrating on this triangle here. So in this area, what the project aims to do is to get this kind of tracking lah. Oh, kuatnya. Right? So you get the idea lah. Kita nak track the pedestrians, the cars, what are their speed, what are their activities in the township itself. Right? So during phase one, SIC have deployed fiber optics. We've been tasked to develop um, PRS app. PRS is public response system, right? Is where the residents of the township can report if there are any problems lah, right? So they've set up their network operation center here in NOC. They have their command center and they've deployed a lot of IoT LoRaWAN wireless devices lah. So most of them are CCTVs, smart street light, and environmental sensors. So we've been working quite closely with SIC to deploy all these sensors and give analytics uh, to PKNS lah. In order to achieve this, a lot of infrastructure have to be installed. So they have their servers using connected through fibers to their NOCs. We have LoRaWAN's IoT devices here. We have CCTV cameras connected also by fiber to the main server, and all of these are feeding data to our cloud server for further processing and then provide those analytics um, to a dashboard or to a an app lah, or public response system, right? Right, public response system to the app, right? So early on, this is the kind of detection that we can do in the area. Our early model can only detect vehicles, but they are quite generalized lah. If it's a car, then it's a car. If it's a lorry, it's a lorry. But as you know, um, a car itself is quite broad, right? An SUV is a car. Um, MPV is a car. A sedan is a car. So, oh, I didn't include the details punya video, right? So, but the current model that we have right now is we can differentiate between sedans, hatchbacks, MPV, SUVs, and so on. This is important so that we can give an estimation of the carbon emission in an area. Like we have this roundabout here. We can do counting using object detection. We can do counting. We can count how many cars have gone through this roundabout, how many trucks, how many buses, how many motors. We can find the average carbon emission of a vehicle according to the types lah. And then we can use this data to calculate the estimated carbon emission. So because SIC and PKNS wants this township to be green township, um, there are certain kind of rules lah. There are certain conditions that they need to um, adhere to comply, right? So they need this kind of data to prove towards the authorities lah that this township is actually green and smart lah. So using our counting, we can count how many vehicles went through the roundabouts, and we can do the CO2 emission estimation lah. So this vehicle counting can also be implemented, I think, for business entities that wants to do traffic analysis before they open their franchise ke macam tu kan. They need to do the foot traffic analysis or vehicle traffic analysis in an area before they deem the place is suitable to open their franchise or not, right? So this can be applicable in a lot of places. Also, through vehicle detection, we can also do LPR, license plate recognition, which right now is being used widely lah, especially in parking spaces in shopping malls. So our own in-house built LPR detection system will soon be deployed in Unimap, where our own keselamatan lah, Jabatan Keselamatan, they want to know um, what kind of vehicle is entering the campus, what's their number plate, how long they are inside the campus, and so on. So they want those kind of analytics for their own use lah. So LPR detection is we can get very good accuracy actually, even with modified number plates, fancy number plates. Kan ada number plate yang cantik rapat-rapat tu kan, right? So but our in-house LPR model can detect those quite good lah. Right. Okay. Now we are not just focusing on um how to say. We also delve into sports using our eye track technology. So for those of you who enjoys football or soccer, so this might be interesting to you lah. So we've developed something called Sport Viz 360. Sport V 360 is a tracker that football player use during match, during the match or during the game, to record their heart rate, VO2 max, so we can get the workload, how many calories are burned. Since we can track the position of the players inside the pitch as well, we can deduce those data. We can get the running speed, dribbling speed, and so on. We also put the same tracker, but just the chip lah inside the football itself, right? So using our AI, um, in general, the AI detects if the player is near the ball and how the ball moves towards how the ball moves inside the pitch. The AI will give the classification of actions lah, whether the player did a pass or a shot, or did the player did a tackle, something like that. So we can get all this tactical analysis using this tracking system. So the development of this tracking system, we work closely with Nano Malaysia and also ISN, Institute Sukan Negara. It is a portable system. We can set up in minimal time, around 10 to 15 minutes. We can get the game running lah. This is Ideria with PDRM FC in KL. In KL, I don't remember where. In Klang Valley, right, with PDRM FC. So this system has been tested by professional teams, by certified academies, by um, primary and secondary school students, and we can get very good analytics and live statistics of the game. Um, Quite accurate lah, very accurate actually. Right, so the system comes with the tracker, a tablet, and the app can also be loaded into your phone lah. So the data that we get from the tracker is actually just raw numbers, numbers of um, coordinates of the players on the field, the measurements of SpO2. Um, then we use those numbers and estimate the position of the players inside the pitch, estimate how much work has been done by the players on the pitch, how much calories are burned, what kind of actions they do, uh, and so on lah, to get those kind of analytics. So for the action part, we have expand for the action classification part. We try to expand um, the accuracy of it by adding a smart insole, which can be used for football, but this smart insole can also be used for fitness or rehabilitation use, or for any recreational activities lah. Because we can do performance analysis or gait analysis. So there are different types of insoles for your shoes, as we all know, right? So, but there are specialized insoles out there by a lot, some of these companies, right? You have Suratec, Plantiga, Salted, and Sensoria. So in their insoles, they have their own sensors, and some of them even have their own apps to give some kind of analytics, or your gait and for or gait analysis, to give you an insight whether um, your steps or how much force are you putting on your um, ankles and so on. Are your steps balanced or not? Are your dominant foot left or right? So those kind of analytics are quite important for physios in rehabilitation, quite important for coaches for sports, and so on lah. So the use case is quite broad. So we at Ideria and also in Unimap, we try to create our own lah in-house solution. So we created an IDE lah, interdigitated
Interdigitated apa? Right. Electrode, right? Where we deposit graphene-based sensing material lah on it. So this is an in-house design, and we fabricate it outside lah. But the design is in-house. The idea is to map these key points on our foot, and measure and try to get some sensor measurements on it, right? So we did some testing, um, compression test, tension test, and so on. We can get the resistance of the interdigit. Based on that, we can map which point on the um, insole itself, dekat mana we put extra pressure or extra force. So then we can analyze lah whether or not our gate is normal or abnormal. So this is just an example that one of our students did lah, um, to map the uh, force applied on our feet or foot. So another example. So this one is using MATLAB, right? Right, it's a live demonstration lah of the sensors that we made. So, but these are still early days of the project. We have a couple of prototypes ready. But we need more data lah to develop the AI. Just now the the map areas um, are not AI based, but we will use those kind of data later on, when we want to try to classify what kind of actions that the user is doing lah. Um, to improve on the install itself, we also incorporating IMUs, initial measurement unit on the insole. So this is the current design right now. We have a soft fabric layer on top. We have an IMU in between the fabric or rubber layer with the smart insole. So from the IMU, based on the IMU, if the user is wearing the insole with the IMU, we can get acceleration data, acceleration signal from the IMU lah. So this is preliminary experiments lah that one of our students did. So dia jalan slowly around the lab to see what the raw signal looks like. So based on the raw signals, we can see some patterns on it lah. Some patterns, recognizable patterns. So manually we can get, this is the point of toe off, this is the point of heel strike. So in gate analysis, these are the two parameters that are quite important lah to calculate um, stride length, um, apa lagi lah, how fast it's walking macam tu. There are few gate analysis punya results that will depends on these two key points here: the time of toe off and the time of heel strike. Toe off is when your toe uh, goes off the ground, and heel strike when your heel strikes the ground lah. So using those two parameters, we can calculate our gate analysis. We can do our gate analysis. But to get these two point of interest here, before this, the students have to manually try to mark this position to do the gate analysis. We try an AI approach, like a deep learning approach to this. So we implement a post estimation solution. So using cameras, this is during data collection. The student is wearing the smart insole with the IMU, right? So we have to set up a camera to get the post estimation of the student who so that using post estimation we can get this the coordinates of the joints, right? So by feeding the model with the coordinate of the joints, important joints je lah. So for this case, we want joint number 27, 28, 29, 30, 31, and 32, which is here lah. Left ankle, right ankle, left heel, left foot index, and right foot index. So we want these 5 joints here with the IMU measurements here, and also the FSR or smart insole measurements from the smart insole lah. Right? We want all these measurements to be the input for our AI model, and we try to label them with the labels are the types of actions that the users or the users is doing lah. So it could be, in this case, it's kicking. So there are a few types of kicking that the student is studying right now. In-step kick, out-step kick. There are a few more that I forgot. So the labels and the data input itself is needed in order to automatically detect the time of toe off and heel strike so that we can do the gait analysis. Uh, um, if this is successful, we can eliminate the tedious manual labeling or manual extraction of these points lah. So this is an ongoing project right now. Yep, to be continued. I received this slide from my student. It says to be continued. So she's still trying to improve on the work. If the auto labeling works, it will reduce the time of data processing or data analysis for the student quite a bit. Right. I think, yep. I think that's about it from me.
Okay.
These are some of the products that or research that we did here in Idaria, also Unimap. So I open for Q&A. I return back to you, Proaza. Thank you
Okay,
very
thank you,
much.
Dr. Shakaf. Okay, so I think you see the point now, because we have learned about fundamentals, basic, and now sort of the application. Okay, so and combining with AI or data analysis, and how we actually starts from fundamental sensors into application in real life. So I open for questions. Oh, it's too foreign for you? Okay. Anyone?
Yeah, could be anything. If you
Mm.
guys have your data set ready, nak tanya macam mana nak train ke, boleh boleh.
They start to learn MATLAB in one of the subject, statistical
Mhm,
subject. So I
mhm.
think. Okay,
Doctor,
so yeah,
Doctor,
Pavitra.
I don't have any question because all of this is very new to us. I just want to tell for as a students who are just
Mm,
learning about sensor, we are
Mhm.
really amazed about all of this. I have to be very truthful that this is the first time I get to know that we
yeah.
can do a lot of things with sensor.
Mm.
Yep.
So that's the purpose, lah, Shakaf. Okay.
Okay, I see, understand.
Mm.
Because me myself, because I'm involved in mechatronics engineering, from my experience lah, or from my point of view, mechatronics engineers are more like applications engineers,
Mm.
right? So we receive all the data from you guys, and
The
we are
fundamentals.
the ones who think about what to do with all these things, the sensors, what kind of application that we want to build, right?
Mm.
So we're mostly on um the part hujung-hujung of a research lah.
Application side. Okay.
Yep.
Okay. So I know that they thinking about it. Okay. because this is the first time probably they're looking at the engineering side. All this while we're talking about all the fundamental on the molecular surface, and we are moving towards IDE. We have talked about IDE before, and then microfluidic a bit, and now is towards the end. Okay, so I think thank you so much, Dr. Shakaf, and congratulations to IDERIA team for superb and
Thank you, Prof.
projects. Yeah. Okay, I wish everybody good luck. I hope that I mean you can contribute more to us in society with all this technology. So thank you so much, everybody, for joining us